Hello, my name is Dr. Luke Bell. I'm lecturer in molecular horticulture at the University of Reading in the United Kingdom. This is a screencast of material originally made available for the module Principles of Horticulture and Crop Production from the years 2020 to 2025. Please note that some of the details may now be outdated.
So learning outcomes are to describe the optimal temperature and soil requirements for growing carrot crops, explain the nutrition and irrigation requirements of carrot crops, and explain how seeding density influences carrot root development and the market specification, and give examples of a few common pests and diseases of carrot crops. So in terms of growth and development of carrot crops, carrot is generally resistant to light frosts and cold temperatures, but prolonged exposure to prolonged and repeat exposure to sub-zero temperatures can kill the plants. Seedlings generally tolerate cold temperatures much better than mature plants, but growth is generally slow below 4 degrees centigrade. The optimum root and foliar growth temperature is about between 16 and 21 degrees C. Temperatures above 21 degrees C can stunt the growth of roots of some cultivars, making them short and stubby. Temperatures less than 16 degrees C favour longer root growth, and foliar growth is inhibited at temperatures above 30 degrees centigrade. Large day and night temperature fluctuations can help promote much more faster growth than a narrow range of temperature fluctuations between night and day. Colour formation is also determined by growth temperature, and the optimum for colour formation occurs between 16 and 25 degrees centigrade. So carotenoid biosynthesis, the pigments which cause the colour in carrots, the development of this kind of lags behind the growth of the roots. So very young roots can often appear to be a very pale yellow or very pale orange colour compared to the mature roots. So this develops over time, and optimum colour is generally achieved after about 90 to 120 days of growth. So in terms of field preparation, what is the optimal field characteristics and soil characteristics for growing carrots? As I mentioned in the previous screencast, some cultivars which tend to be short are quite tolerant of heavier soils, but the longer, more tapering cultivars of carrot must be grown on deep soils which are well drained and very fertile, so typically a sandy loam. So long-rooted cultivar growth is generally inhibited by shallow or compacted soil. Also soils which have large clods within them or large stones, for example, can disrupt the growth of the taproot, and so it can cause malformations in the root and a phenomenon which is called fanging. And so this is where the base of the tip of the root splits in two, and so kind of resembles two fangs, and those roots then begin to grow in different directions, and so that's often considered an undesirable characteristic of carrot crops. Carrots are generally tolerant to a wide range of pHs, but the optimum is between about 5.5 to 6.8, though this does vary slightly according to the soil type which is the crop is being grown on. So again, fertilizer rates will also be dictated by the soil type and how free draining or sandy it is. But the average carrot crop will uptake about 162 kilograms per hectare of nitrogen, 28 kilograms per hectare of phosphorus, and quite a large amount of potassium, so 386 kilograms per hectare of potassium. So it's essential that adequate potassium is provided to the crop, whereas excessive nitrogen can promote overgrown foliage, and this comes at the expense of the growth of the roots. So it's important not to over fertilize with nitrogen on a carrot crop. As I also mentioned in the previous screencast, carrot seed quality can be quite variable because of the different developmental stages of the seed on the plant, and so for that reason germination can be quite varied. It can be slow and inhibited under high temperatures, and so under adverse conditions it can take quite a while for a carrot crop to become established. Techniques such as seed priming can help improve the germination rate and emergence uniformity of carrots. So the seeding density of carrots is quite important for determining its growth habits and also for its market specification. So bunching or fresh market carrot roots may be seeded at a density of about 400,000 to about 550,000 seeds per acre, whereas the Chardonnay types, which are much smaller and have a shorter growth cycle, can be sown at much higher densities to facilitate this. So you can essentially get more roots out of the land because they don't need to be as grown in the field as long. So the seeding rate of a Chardonnay type can be as high as 4 million seeds per acre. This will also influence the number of rows and the widths and spacing between the rows. So your standard early and main crop carrot productions will have probably a standard width of about 18 inches or so apart, whereas the Chardonnay types, as I said, they can be sown in much higher density, probably in triple rows, in tandem rows, to facilitate a higher density of production. Irrigation of carrot crops is very important, so it's important to maintain an even soil moisture content throughout the whole of the carrot growth season. Uneven water availability, so if the soil moisture content drops below about 60%, it can cause roots to start to become woody, and a term which is often used is pithy, so it becomes very difficult to eat the root if it becomes woody and pithy like that. So that's an undesirable characteristic that can develop as a result of water shortage. Roots also typically have reduced carbohydrate content under low water availability, and they can start to taste bitter as well. So the plants get stressed and they start producing compounds which have an undesirable taste and flavour. So generally crops require about 30 to 50 millimeters of water per week. This may vary according to soil type, so a sandy soil may need irrigating a bit more than this and a bit more frequently. But at the same time, excessive moisture, particularly around this time of harvest, can cause some carrot cultivar roots to crack. So this typically happens when the roots are lifted from the ground and there's a change in the turgor pressure within the plant. So when the taproot is severed from its roots in the field, that change in pressure can then cause the roots to split. So in terms of harvesting, I'm not going to go into too much detail in this screencast because it's been covered in a previous one on harvesting methods last semester. But just to cover it very briefly, carrots are typically harvested according to their maturity and the size of the root according to the market specification. So carrots are typically machine harvested and lifted from the field, so you can see that happening here in a machine which is called a top lifter. So it's lifting the roots out by its foliage, and then that foliage is being trimmed off, and then the roots are being deposited in those wooden bins you can see behind the machine. So some machines are much larger than this and are capable of lifting the carrots, trimming them, and even packing them within the field. In terms of storage, post-harvest carrots should be cooled pretty quickly and should be stored at about 1 to 2 degrees centigrade. The roots may be further trimmed and washed in a processing line, and as I've covered that in the previous harvest procedure screencast, I'm not going to go into it in too much detail here. So what I will go into a little bit more is types of pests and diseases which might affect carrot crops. So there's one particular fly which is quite a large pest of carrots called the carrot root fly, and the Latin name is Scilla rosae. So this causes significant damage to the roots, and you can see here that the maggots of this fly kind of burrow their way through the roots, causing these holes and lesions on the surface of the carrots. This is a particularly badly affected crop. It might not always be as bad as this in some fields, but they can be quite devastating. And obviously this can potentially wipe out entire crops because the roots become inedible. Next we have the root knot nematode. So this is a group of different species of nematodes, but they generally cause the kind of symptoms you can see in this slide here. So the nematodes kind of bore into the roots, and they the stress response of the carrot is to produce these gall-like structures on the side of the roots, and so these can be obviously very distorting to the growth of the root, and they can, completely ruin the appearance and edibility of the crop. So these infestations can be quite severe. Then we have a sort of milder disease, I guess, called cavity spot. So this is generally caused by Pythium species. So it affects carrots, but also parsnips suffer from this disease. So it's a pathogen which causes these black spots to appear on the surface of the skin, and it's generally where some previous damage has occurred and the pathogen has got in and it started to cause this infestation and cause these undesirable blemishes and pits within the surface of the skin. It can result in unmarketability if severe enough. So in summary, carrot is a cool season crop capable of withstanding mild frosts. Plants have a high demand for potassium, but nitrogen nutrition must be closely monitored, and it's important not to over fertilize carrots with nitrogen. Carrot crops require consistent irrigation to maintain root growth and quality. Seeding density is dictated by the market specification, with higher densities used for growing smaller, thinner and stubbier roots. And carrots can suffer from different diseases such as Pythium and nematode worms, which can lower the quality or even destroy whole crops.